everyone, welcome to OCTEMY. In the previous video on engineering mechanics, I have discussed about the weightage in various competitive exams, syllabus, and then books. What are the different types of reference books? In this video, I'll be discussing about the basic things like what do you mean by a particle. In the syllabus, while defining, I have mentioned kinematics of particle, kinematics of rigid body. So we'll see here what do you mean by a particle, rigid body, and first of all, what do you mean by mechanics? Okay, so we'll see in this video these three basic terms. First, what do you mean by mechanics? What do you mean by mechanics? Listen to me carefully, sir. Let us take, I'll take some body, your wish, I don't have any objection. You take some body, this is body, I have here bottle, I have taken a bottle, okay, I'm taking a bottle, just some body, your wish, you take a bottle. Now I will do some action. What do you mean by actions? Your wish, maybe see, I started pressing it, it's moving. Is it moving? No, because the ground is supporting it. So as I'm pressing it, it is counterbalanced by this, right? So I'm pressing it, it's not coming into motion, but what is happening, it may deform, it may get some deformations. Maybe it depends upon the strength. Suppose let us say if I press like this, you can see the deformations. If I press like this, you cannot see the deformations, right? It can undergo some deformations. There may be here there is deformation, but you are not able to see it, but there is support which is offering support reaction. Maybe suppose let us say instead of pressing it, I pushed it. Now what happened? It's moving. Can I say it's under translation? We'll name it, right? It's under some translatory motion. The same force I'm applying at this point. Now what's happening? The same force I'm applying at this point. Now what's happening? The body is rotating. Some different motion, some different kind of motion. That means for each and every action, maybe I'm pressing it, pushing it, maybe pulling it, based on different types of actions I'm doing on the body. When I do some actions on the body is behaving in different fashions. What may be those different effects or different things that are happening? Maybe motion. Maybe if it is not moving, it can have some support reactions, even it can deform, right? So the study of these actions and its effects, is nothing but known as mechanics. So mechanics is the science which deals with actions and its effects. These actions we call them as force. See, I'm pushing it, that's a force, I'm applying a force. I'm pressing it, I'm applying a force. I'm pulling it, I'm applying a force, right? So these actions, we call it as technically force. And what may be the effects? Maybe when I press, the ground is supporting it, it's developing a reaction. So there may be a reaction. When I start pushing it, it started translating. Maybe it is getting displaced, it got some velocity, it may be accelerating, anything can happen. So all these we call it as motion variables. So now what is the target we are going to have in this mechanics is to find the relation between these actions and these effects, right? So start developing the relation between these actions, reactions, and motion variables is all we are going to deal in mechanics. So what do you mean by mechanics? Mechanics is the science which deals with actions and its effects. What do you mean by actions? Forces. What do you mean by effects? Maybe reactions, maybe the motion variables, displacement, velocity, acceleration. So mechanics is the science which deals with actions and its effects. So what's the target here? How, when I apply a force on the body, when I do some action on the body, how it is going to behave, and relating that action and this behavior is all we have in mechanics. That's what is mean by mechanics. Okay, so mechanics is the science which deals with action and its effects. Now we'll see what do you mean by a body and what do you mean by a particle. First, what do you mean by a body? Anything, you take anything near you, maybe a bottle or a book or a car or a earth, anything can be treated as a body. Okay, now what do you mean by a particle? Listen to me carefully. When I pose this question in class, so from the past 4 or 5 years, I am observing what the students give, right? They'll say it's a smallest particle, indivisible part, maybe atom, very small mass, or some people will say all the mass is concentrated in that particle. Like that, I'll get many answers. The whole meaning of everyone about a particle is that it's a very small one. Actually, yeah, maybe that you can, if you go with the dictionary meaning, it may be the same one, but what I mean practical in mechanics is it's an idealization, it's an assumption. What do you mean by idealization or assumption? I'll say a small out of the subject concept, that is a story, then we will relate to this. Okay, so generally it's my way of teaching with some examples. So let's have it. Let us say I have a just born baby, immediately just born baby, okay, some few hours. Now the baby is crying, she's crying for, as because of hunger she is crying. Now what will be the first food the mother will feed? Obviously milk. Yes or no? Sir, when the first time baby is taking the food, why she is giving that milk, no sugar, nothing, it will be a bit sour in taste and all. Why not something like a good chicken biryani or some payasam or something like a delicious dish? Why they are not giving some good sweet? See, why are they giving just that milk which is not at all tasty and smelling? Why they want to give that? Because the baby is not in a position to digest it. So we are just feeding it milk which is easily digestible. Slowly we are making the digestive system to grow. Then we are feeding with maybe rice, and then with some small curries, and then finally small chicken or sweets, whatever it is, and then we will grow up, right? The same way here, I have a complex problems like earth is moving, the rocket is moving, a missile is launched, a car is moving. There are many complex problems, motions happening around me. I want to analyze them. I want to construct big dams where I have to do big force analysis. I have trusses. All these things are a bit complex. They are very there is many concepts involved in it. At this level I am not in a position to digest it. As I am not in a position to digest it, what we do is we will idealize them. We will make some assumptions and we will idealize them. So here assumptions in the sense, so I cannot, this is complex, to whatever fashion I want I cannot idealize. Based on the problem you can make appropriate assumptions. It's not single, sir. I cannot mention, sir, this is only one. Based on the situation, you can make appropriate assumptions and simplify the problem. First, try to solve it, understand it. Once it is getting digested, then we'll go for the real case, step-by-step increment. The same way as the motion of a body is very complex. Studying the body itself at in the starting is complex. They have made an idealization. What is this idealization? Listen. Let us say I have started from Hyderabad and I have gone to Chennai. I have started in Hyderabad and I have gone to Chennai. Let us say I have come in a car. I have started from Chennai and I have gone to, what is this? Sorry, I have started from Hyderabad and I have reached Chennai. Let us say the road distance is around some 600 kilometers and I have finished the journey in 12 hours. I have started in a car from Hyderabad and reached Chennai, which is at a distance of 600 kilometers in 12 hours. Now, I want to know what is the average speed. What's the average speed? Very simple, 600 kilometers by 12 hours. 600 kilometers by 12 hours. Now, that is 50 kilometers per hour. Am I right? Now, is it required for you the data of what is the length of the car, what are the dimensions of the car, whether it is having 3 meter height or 2 meter height, whether it is having windows or was the doors open or closed, or it's having mirrors open or shut, do you want all this data, dimension, shape of the body? Obviously no. What are you doing it as? You are taking you can see the maps also, they'll take it as a small particle moving in that path. That means they are neglecting the dimensions of it. When it is neglected, compared to that 600 kilometers, the size of the car is very less. Now let us say one more. I am analyzing the motion of a rocket, or okay, let us say rocket, which is going from its orbit to, what is this, from Earth to some geostationary orbit somewhere in space. When it is moving, how they take it? See whether the rocket is having 2 wings or 3 wings, where it is narrow, that doesn't matter for me. When I am analyzing, this is the distance it has traveled in this much of time. So this is the average speed it is going. You take Earth, it's moving around the sun. Now, Earth is very big in size and all these things, but when I am doing the analysis, you will take it as a point moving in an orbit. That means whenever the range of motion is much large. See here, this is a body. Whenever the range of motion, that means compared to the 600 kilometers I travel, the size of the car is less. Compared to the length of the path of the Earth, the size of Earth is less. Compared to the path in which rocket is traveling, size of the rocket is less. Even you take a cricket ball, when it is moving, I'm not worried about the size of the ball and all these things. The path, when you're talking about the path, I'm not worried about the dimensions. I can treat it as a single particle, single point size body. So whenever the range of motion is much larger than the size of the body, I can idealize the body. As a particle or point size body. That means I'm not worried about the size and shape of the body. Right? Whenever the range of motion is much larger than the size of the body, I can treat the body as a particle. That means if the body has traveled 50 kilometers, I'm taking that I have treated as a particle. Now this particle is traveling that 600 kilometers from Hyderabad to Chennai. This point is moving in the orbit of the earth. See, like this. See, if this is my sun, see, when I'm taking its orbit, when I'm taking the earth is moving in the orbit, see, I'll take it as a small object. I'm not worried about whether there is a Pacific Ocean or the Himalayas, what is the shape, what is the radius. I'm not worried about it. Let us say it's finishing this much distance in 365 days. What is the average speed? When I'm calculating that, the size of the earth is immaterial. Even when I'm calculating, let us say, what is the attraction force, gravitational force, between the sun and earth, I'm calculating that. Even then, I will treat it as a sphere. Mass m1, m2, radius is r, and I will start the problem. Here also, I'm not much worried about its shape. I will treat them as a single point and do the problem, right? Whenever the range of motions are much higher than the size of the body, I am okay to treat the body as a particle or point size body. Okay, that means when I say the earth is moving 100 kilometers, that means I'm taking a point. That point is moving 100 kilometers. Now you can ask me, sir, which point I have to take on the body? This point, which point to take? Reasonably good is always any body you take, it will have some mass. When it is having some mass, the weight of the body, that is the gravitational force of the body, the resultant of it is distributed. We have masses. The gravitational force is distributed. The resultant of all these gravitational forces will always pass through one single point, which we call it as center of gravity. So that's why remaining things maybe we can change, but mass is this way distributed. The resultant of the gravitational forces will always pass through that single point, that is called center of gravity. And for the given body, CG cannot be changed unless gravitational field is changing. So I will take that CG as the reference point. So whenever I am talking about a body is moving like this, that means when earth is moving, I am taking the center of gravity of the earth. Is moving in this path. When I'm coming from Hyderabad to Chennai, the center of gravity of the car is moving. Okay, when I say the ball is projected, that means the center of gravity of the ball is taken into consideration. As long as range is much higher than size of the body, I can treat it as a point size body or particle. Even now, let us say I have applied a force on the body. Where to take? When I am treating the body as a particle, see, I am not giving any dimensions. When I am not giving any dimensions, that means I am treating the body as a particle. Then I can take the force at again CG. So now there is a force acting on it, I'll take the force at CG. When there is a force acting on the body, I'll take that at CG. Are you okay? I'm pulling the body. I'm treating it as a particle. Now where to take that force? I'll take that force at CG. Okay. So whenever range of motion is very large compared to size of the body, then it can be idealized as a particle or point size body. One sec. How to identify whether he has given it as a, in the problem, he will not mention I'm treating it as a particle, I'm treating it as a body, like that. How to know whether he has given a body or a particle? Body will have shape and size. If he says I have a ladder of length 5 meters, a sphere of radius 5 meters, that means he is mentioning the dimensions and shape. That means he is treating it as a body. As long as he is not giving the shape and size of the body, he just says a car is moving, a ball is thrown, that means he is treating it as a particle. That's the blind assumption. It's a thumb rule. I'm not saying it's the definition, but what's that? It's a thumb rule. What we follow is whenever the range of motion is large, we can treat the body as a particular point size body. The thumb rule how to identify a question is whenever he mentions the shape and size, that means he's treating it as a body, otherwise particle. Okay, now I have one more, that is, what do you mean by a rigid body? Because in mechanics I'm only going to deal with rigid bodies. So first let us define what is a rigid body. Obviously we'll say the body which is not going to deform or which will not change its shape and size. All these are correct, sir, but I will make a better definition. What is that better definition of it is, let us say I have a body. You take any body, your wish. Okay, I have a body. On this body I am taking some 2 points, not only P and wherever you want, here, wherever you want, to take some 2 points randomly, your wish. You take 2 points, let us say P and Q. Now let us say the distance between both the points is L. The distance between both the points is L. Now you take the body. Now you press it, you pull it, you squeeze it, twist it, whatever you want. See, you press it, you twist it, you crush it, you hit it, whatever you want to do with the body, but still the distance between these 2 points, which 2 points, any 2 points your wish, you take those 2 points, between them is L. That distance between any 2 points L should always remain constant. It should not change. Then I can say that body is a rigid body. Again, this is also one type of idealization, because in nature there is no exactly perfect rigid body, but based on the circumstances. Suppose, let us say I'm taking this body, when I apply a force, it's getting deformed. The deformation is considerable, so I cannot take it as a rigid body. But when I'm applying a force like this, maybe if I apply more force it will deform, but for the force whatever I'm applying, the deformation is very less, very less. So I can idealize and treat this body as a rigid body under this condition. Okay, so I told, based on the type of situation you can make the idealizations. So there is no perfect rigid body, but we have many situations where we can treat the body as a rigid body, exactly speaking resistant body, but now I'm not going to talk about. I'm taking here in mechanics every body as a rigid body. That means you take any 2 points on the body, the distance between them will always remain constant. If the distance between any 2 points will always remain constant, then that body is not known as a rigid body. Distance between any 2 points should always be constant, then I can say the body is a rigid body. I will say one more definition also. What is that? Is just a modification of this. Instead of P and Q, you take number of points. Let us say here I am taking P1, here P2, here P3, like that. You take some your wish. Now let us say this distance is L1, this distance is L2, this distance is L3, this distance is L4. Like the relative distance between any 2 points, and the relative distance between the points should also be constant. Not only 2 points, that's why I said any 2 points. What's the meaning of this any 2 points is, you take your wish, you take many points also, the relative distance between all the points should be constant. Why I'm giving this is, some books are not going with this, some are going with that. What they say is the relative distance between the points, the relative distance between many points, whatever the points you take, corresponding points should always be constant. So that's why I'm saying I'm taking 2, but the 2 points your wish, wherever you want to take, any 2 points you take, that should be constant. Or many points and the relative distance between those points should also be constant. Anyway, it's fine. Okay, the same definition, I'm just elaborating it, that's it. Okay, but I'm not just okay with this definition. This is, I can say, something like a static definition, but I want more analysis of this, that is the kinematic definition of it. What do you mean by this kinematic definition? Please, all of you see here, I have a body, I'm taking again 2 points and the distance between them is L. Now the point P is having a velocity v1 at an angle theta1 making with PQ, and the point Q is having a velocity v2 making an angle theta2. Now, what should be the relation between these velocities v1 and v2 so that I can treat the body as a rigid body? And if it is a rigid body, what should be the relation between v1 and v2? If it's a rigid body, what should be the relation between v1 and v2? Anyway, it's fine for me. Now, please, all of you see. First, I will resolve these velocities. If I resolve this velocity v1, as this angle is theta, it's you just take the triangle, okay? This is adjacent side, so it is v1 cos theta 1. This is opposite side, v1 sin theta 1. Similarly, I will resolve even v2. If I resolve v2, this is the adjacent side, v2 cos theta 2, opposite side, this is v2 sin theta 2. Now, listen. For the time being, I am not taking these two into consideration. Forget these perpendicular ones. I will come for them also. For the time being, forget the perpendicular ones. Just take this body is having a velocity v1 cos theta 1 along this line joining PQ. The body is, this point P is having a velocity v1 cos theta 1 along the line joining PQ, and Q is having a velocity v2 cos theta 2 along the line joining PQ. Now, instead of 2 points, let us assume this is one bike and this is one more bike. 2 bikes are there. Okay, this bike name is P, this bike name is Q. if I want the distance between both the bikes, let us say the distance between both the bikes is L. Now, when will the distance between both the bikes will be always same? If suppose this guy is coming at 100, this guy is going at 50, 100 km per hour, 50 km per hour. What happens? As this is at a higher speed, it will come closer and the distance will reduce. If suppose this guy is at 100 and this guy is at 50, then what will happen? This guy is at higher speed, the distance will increase. For the distance to always remain constant, these two velocities should be always equal. If this is at 50, 50, then this is L. If this is at 100, this is 100, then it is equal. That means both the velocities should be same. Both the velocities should be same. Or I can say the relative velocity. What do you mean by relative velocity? When I sit here and find out the velocity of this, if this is 100 and this is 50, there is a difference in the velocities and there will be some relative velocity between them. If both are at 50, 50, 100, 100, then if both are at same speed, what will happen to the relative velocity? It will be 0. Both are at the same speed. What's the relative velocity? 0. That means the relative velocity between 2 points P and Q, any 2 points P and Q, along the line joining them, should be equal to 0. Listen. What's that? These two velocities should be same. If these two velocities are same, what's the meaning of that? The relative velocity along the line joining them should be equal to 0. That means velocity of point P along the line joining PQ should be equal to velocity of Q along the line joining PQ. That means relative velocity of P with respect to Q or relative velocity of Q with respect to P along the line joining PQ. Along the line joining PQ should be equal to 0. Then I can say the body is a rigid body. Because the dimensions are not changing. Okay. See, I want finally this L should be constant. That's what is my target. This L should be constant. For that, who are affecting that length? This velocity and this velocity. If they are equal, that means relative velocity between the 2 points is 0. Then it will be constant. So the relative velocity between any 2 points with respect to each other along their line joining is 0. Then it can be treated as a rigid body. So from the static definition, what is that? Distance between any 2 points should be always constant, or the relative velocity between any 2 points along the line joining them should be equal to 0. Are you okay? Listen to my words carefully. The relative velocity, that means velocity of P with respect to Q or Q with respect to P, not their individual velocities with respect to ground. Okay? Because velocity is always relative. That is with respect to each other, not with respect to ground. The relative velocity between any 2 points with respect to each other along the line joining them is equal to 0. Very good. We have seen these two. Now, what about these two? They are not affecting anything to my rigid body, sir. But what happens with them also? We'll have a look before closing this. Okay? Now, please, all of you see here. Now, the velocities. How are those velocities? Perpendicular to this. Okay? Now, what happens if both the velocities are also same? If suppose both those velocities are also same, what is happening now? See, if both these velocities are also same, how is the body moving? If both those velocities are also same, how is the body moving? See, if this velocity and this velocity are same, then the body is covering. See, the P is moving from here to here. That means, let us say if this distance traveled is L, this distance traveled is also L. Both are having same velocity. If each and every point on the body is having same displacement, same distance travel, we call that as the body is under pure translation. And as both are having same velocity, just now I told you, if both are having same velocity, then what will be the relative velocity? What will be the relative velocity of P with respect to Q or Q with respect to P? This is not along PQ. This is perpendicular to PQ. Is also 0. Because both are same. So relative will be 0. V minus V. Velocity of P with respect to Q or Q with respect to P. With respect to ground it is V. But with respect to each other it is 0. That means if the body is under pure translation, even the relative velocity in the perpendicular direction is also 0. Even the relative velocity between the 2 points, any 2 points in the perpendicular direction is also 0. What happens if the body is not under pure translation? or if the velocities are different. See, now let us say this velocity is higher than this is more than this. So what's happening? It's covering more distance. See, I have a body, I have given both same velocities, so it went in a both are in a straight line, as both are traveling same distance. But now I am giving here more distance, more velocity, here less velocity, so it will travel more, it will travel less, it will travel less, it will travel more, like this. Okay, that means, see, the distance covered by this, let us say this is L1 and this is L2. Obviously L1 is greater than L2. Why? The velocities are not same in the perpendicular direction. Okay, so if the velocities are not same in the perpendicular direction, then the body will not be under pure translation. So we can say either rotation or the body, some motion, some random motion which is having a rotational component. It's not pure translation. Apart from pure translation, it can be anything. Here the body is undergoing rotation, here the body is undergoing rotation. Any combination of translation plus rotation can also be there. That is called as combined motion or some random motion or general motion, whatever you want. So if there is some rotational component, then both the perpendicular velocities will not be same. That means the relative velocity is not relative velocity of P with respect to Q or Q with respect to P. Magnitude wise they are same, but this is not equal to, they are not equal to 0 in the perpendicular direction. Is not 0. So along the line joining is 0, but perpendicular is not 0. So what happens to the velocities perpendicular to the line joining for a rigid body? May be 0, may not be 0. If the body is under pure translation, it is 0. If the body is not under pure translation, it will not be 0. That means for a rigid body, the relative velocity along the line joining them, should be 0. You cannot have any relative velocity component along the line joining them. But perpendicular to that, may be 0, may not be 0. You can have a component, relative velocity component perpendicular to it. If it is 0, it's under pure translation. If it is not 0, then it will be having some rotatory motion. Maybe a combination of translation and rotation is also possible. It will have some motion which is not pure translation. Are you okay? Let me finalize what do you mean by engineering mechanics. Then I will go and do some 3-4 problems, then we will close this. Another 4-5 minutes I'll take, just that's it. So mechanics, so what do you mean by mechanics? I have discussed is the science which deals with actions and its effects. I have a body, I have applied a force on it, I have done some action on it. So what can happen to the body? It can undergo deformation, it may not undergo deformation. If suppose it is sufficiently strong and or else I have a rigid body, somewhere I have a rigid body, I have done some action on it. Okay, I am idealizing the body as a rigid body, I have done some action on it, it's not deforming, non-deformable. In generally they will deform. So if the body is not deforming, we call it as rigid body, and that science which I deal with it is nothing but known as engineering mechanics. So we call here in our Indian curriculum or on our gate, we call it as engineering mechanics. So where I am only going to deal with non-deformable rigid bodies. So all that in this course we have is rigid bodies which are not undergoing any deformation. The relative distance between any 2 points will always remain constant. The relative velocity along the line joining them is 0. Perpendicular to that, I don't know, maybe 0, may not be 0. If it is pure translation, 0, otherwise not 0. And if the body is deforming, that's what I'm going to do in engineering mechanics. If the body is deforming, it can be 2 ways. Either it can undergo finite deformation or continuous deformation, that is infinite deformation. Finite deformation is not what we are going to deal under strength of materials or mechanics of solids or mechanics of materials. Infinite deformation is what is called fluid mechanics. Okay, so in this course we are going to have with engineering mechanics, that is with rigid bodies. Okay, so quickly I will see some 3-4 questions and close this. Okay, an object has to be assumed as a particle. An object can be assumed as a particle when size of the body is very large. No, I am not worried about the size of the body at all. What I am worried is compare it to the size range of motion. What is the size of the body, right? So size of the particle is very large compared to range of motion. Not size of particle is very large, range of motion is very large compared to the size of the body, right? So it's the right answer. Range of motion is very large compared to size of the body, then an object can be assumed to be a particle. Are you okay? Next, When a body is assumed to be a particle, the point considered to describe the motion of the body at the point at which forces are considered to be applied is, I told very clearly which point I have to take, which point on the body I have to take, that is center of gravity, because the resultant of my gravitational force will pass through that point which I cannot change once the body is given. So I will take that point, that is my center of gravity. Okay, next. The distance between any two arbitrarily chosen points on a rigid body will always be, this is the static definition for a rigid body, he mentioned very clearly, for a rigid body, distance between any two arbitrarily chosen point will always be constant. Okay, the relative velocity between any two arbitrarily chosen points on a rigid body along the line joining them. See, he told relative velocity along the line joining them for a rigid body. So what it will happen? Perpendicular may be 0, may not be 0, but along the line it is 0. Are you okay? This is a previous year question, sir. For that reason I have kept all these questions. You will get revised of them. Now read this. There are 2 points P and Q on a planar rigid body. What body? Rigid body. 2 points P and Q are taken. The relative velocity between the 2 points is, sir, if it is a rigid body, relative velocity between them, he didn't say whether it is along the line joining or perpendicular to the line joining. So, but as it is a rigid body, along the line joining, relative velocity is 0. Perpendicular to the line joining, it may be there, may not be there, right? Now see the options. Should always be along PQ. No, sir. What's the relative velocity along PQ? That is 0. So if you have a component that will be perpendicular to it, it's not along, it's not always along, it's not along PQ at all. Can be oriented along any direction. No, I cannot have it along any. See, he's not talking about that. He's talking about the total velocity. Along the line joining is gone, so that is 0. The only component I have is perpendicular to it. So the total cannot be oriented in any direction. That is also wrong. Can always be, should be always perpendicular to PQ. Yes, yes. See, the relative velocity, if it is not there along the line, if it is there, it should be perpendicular to PQ. Should be along QP when it undergoes pure translation. If it is undergoing pure translation, total 0. Both the components are 0, total 0. So what's the answer? Should be always perpendicular to PQ. Are you okay? So with this, I'm closing this video. So we have seen what's a particle, what's a rigid body, and what is do you mean by mechanics. Okay. So hope you have gained some knowledge from my lecture. If you feel so, please subscribe to the channel. Please leave your valuable feedback and doubts in the comment section. For my complete video lecture series, enroll in OCTEMY. Thank you. Let's catch you soon in OCTEMY. Have a good day.